In this today, I'm going to start with one more question, which was asked in NEET 2024. Uh, so, what is this question? Let me read this question. This graph shows the variation of 1 by lambda square and its kinetic energy E. Yeah, E is what they are asking that where lambda is the de Broglie wavelength of free particle. So, firstly, there are few points which I want to start with again as I start. Firstly, what is de Broglie wavelength? As you know, in dual nature of matter, de Broglie wavelength, de Broglie states that every particle is a wave. Every particle has a particular wavelength. So it may be counterintuitive, but I am not going into that discussion. But I am going to give only the expression first. Let me write it. Lambda is equal to h by h is Planck's constant by momentum. Planck's constant. Then this is a momentum, as you know. This is momentum wavelength. So this is a de Broglie wavelength expression. This is de Broglie wavelength expression. And then kinetic energy. You know that kinetic energy is given by half mv square, right? Half mv square, and the momentum is nothing but momentum is nothing but mv. Momentum p is equal to mass into velocity. Here v is velocity and m is mass. So this is the energy and momentum. So as you know that energy is a energy and momentum. So I'm going to start here. Firstly, I want to find so we know there is lambda, h and p. So I want to bring the expression in terms of 1 by lambda square and e. So how to do it? Firstly, I want to start, this is a graph. So any graph, any equation in a 2D graph can be represented of form. Let me take, this is x and y. This is x-axis and this is y-axis. And there is some graph, some graph like this. So how I can represent this expression? I can so if it is a curve, then we may not know. But for example, let me take an example and find whether it is a curve or these. There are four graphs given, and we have to find the relation between energy and lambda 1 by lambda square. So how we are going to do it? So let me first find relation between energy and momentum. As many of you know, many of me already know it's straightforward. Like I can put the expression of v. So if I take this here, velocity here, I can write this as half mv, this is momentum, into v. But I don't want to have the I want to, in this expression I want to replace replace v. So how I can replace v? I can find out what is the value of v, right? So this is how I can find out what is value of v in terms of energy. V square is nothing but 2e by 2 into e by m. So now v is nothing but square root of this. V is the square root of this. 1 minute. V is nothing but square root of this, so I can take this as like I can write then equal to 2E by m, right? This is V is equal to this one. So now mv, so if I multiply this mv, that is P is equal to m, I can write this as, now I can write this as m is nothing but, if I, there is m in the inside the square root and there is m here outside, so I can write this as square root of m into square root of m into 2e by m. So now the m is inside the square root, I can cancel this and this. So now as two square roots, if I multiply, the square root will remain, but the values inside gets multiplied. So 2 into me. So this is an expression for momentum in terms of energy, right? So this is a expression, and many of you may be knowing this because this is a, oh, like many of you may be directly knowing it, but I am showing the derivation on how to do it if you don't know also, because the focus should be to learn the concept and try to remember as less as possible and solve the questions as fast as possible. So now if we got the relation between energy and momentum, so if I substitute this in de Broglie wavelength expression, lambda is equal to h by 2m square root of me. So now if I bring this energy to right hand side, and 2 square root of 2 into me is equal to h by lambda. So now if I square on both sides, then I will get an expression as follows: 2me is equal to h square by lambda square. S square by lambda square. So now we can see that clearly one thing is observed, that there is a variable E and variable lambda square, and mass and Planck's constants are constants. So this is nothing but an equation of straight line. I can simplify further. Let me write it as follows: 1 by lambda square is equal to 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 if I take this to 2m by h square, by h square. I'm writing the constant separately. Two m by h square into energy. into energy E. So this is what is the expression. So now if you compare this expression with the, if we compare this expression with the expression of straight line, that is y is equal to, let me write with a different color. y is equal to mx plus c, y is equal to mx plus c expression. This is a equation of straight line. Y is equal to mx plus c. I mean, this is slope. So any straight line can be represented like this. Say for example, I'll take a straight line passing through origin, then this is the intercept value is 0. So only y is equal to mx form. So the slope, this is the slope, don't confuse with mass here. This is a altogether different expression in x and y. This is x and y here, y. So this is relation. So now if I compare, y is 1 by lambda square is equal to some constant into energy. So this is in the form of y is equal to slope into x. So this shows that this expression is a straight line passing through origin. So this option number 2 is the right answer. Option number 2 is right one. So this question is little tricky. You have to know a few concepts, and also you have to know how to rearrange the expressions, and then you have to know how to find which are the constants. The mass and h square is a constant, energy and 1 by lambda square is a variable here. So we get the option. This is a good question which was asked this year in NEET. So I will bring few more questions in the next videos. Thank you.